Okay, so we're going to be solving a lot of problems with logs, right? And then at the end, there's going to be a couple problems where we go from exponential to a log problem, and you're going to need a calculator for those, but that's towards the end. Right now, we're just going to be doing basic logs, okay? So what we're going to try to figure out is how to solve for x in this type of problem. Now you'll notice there are logs on the left side but no logs on the right, which means I have to introduce the log. Okay, we kind of did that yesterday, we did that on Friday. And then also notice there is an addition in this problem, right here there's a plus sign. So that plus sign is supposed to tell you that you're going to be gathering these things and multiplying them. Okay, so anytime you see addition within logs, that means multiply. So if I rewrite this, this is going to be log base 3 of x times x minus 8 equal to, all right, so that's the multiplication part. And remember, for the 2, we can't leave it like that. We have to write log base 3 because it has to match. And then you write a 3 right there because that little base 3 becomes a big number 3. You got to do that. And then that 2 ends up on top. Okay, just like that. That's the little trick to create a number into a log. Now, since they both have a log base 3, that means that I can now multiply out what I have in here and set them equal to each other. So there's x squared minus 8x equals 9. And remember, anytime you see an x squared term, that means we're most likely going to have to use an x method to factor. So first thing you have to do is set it equal to 0. So I'm going to move that positive 9 over by subtracting 9. So this is x squared minus 8x minus 9 equals 0. Okay? At this point, you're like, okay, I'm ready to factor. So let's get ready to factor here. On the top of the x, you're going to multiply 1 times negative 9. That's your a times your c. So that's negative 9. On the bottom, you're going to put your b value. That's negative 8. And two numbers that multiply to negative 9 but add up to negative 8 would be a negative 9 and a positive 1. So this is your factor, x minus 9 times x plus 1 equals 0. Okay? At this point, you have to break that apart and solve. Okay, so we're going to kind of come back up here. If you look at all the other notes that we did, we always tend to do that, right? After we factored, we always kind of drew an arrow and started working to the side. So here you go. X minus 9 equals 0. X plus 1 equals 0. So I'm going to add 9 to both sides on the first one. So I'm going to get x equal to 9. And on the other one, if I subtract 1 on both sides, I get x equals to negative 1. Now remember, at this point, good for us. We solved. We're good. But you got to check, right? You always have to check your answers. So you're going to do a quick check step for 9 and for negative 1. Okay? So let's plug it into, it's any one of these right here, okay? This one or that one. All right, so if we plug it into x minus 8, we're going to get 9 minus 8, that's 1. Okay, so I'm plugging in a 9. And for the other one, if I just plug it into x, well, I'm just going to get a 9. Both are positive, right? So that's good. That's good, nothing wrong with that. Now let's try plugging in the negative 1. If I plug in the negative 1 into x minus 8, I get negative 1 minus 8, which is negative 9. That is not good. Remember, our check step cannot result in a negative answer. So this one does not work. This one does. Okay? So that's your answer for number 1. Okay, only 1 out of the 2, correct? Go ahead.
How can we subtract it by 8?
You see right here, this part right here, x minus 8. So I'm plugging in a 9 into that little portion. So the x becomes a 9 and then it's minus 8, right? And then for the other one, I plugged it into where the x is. And that's kind of repetitive. You're just plugging in a 9 right there. So it's just a 9. But yeah, you always plug it into the portion inside the log, because the rule is that the log value inside cannot be negative. So when you do your check step, if your answer is negative, that means that it doesn't work. Okay? So, all right, so there's question number 1. And there's like a couple of these, like 2 or 3 of these, so just so you're aware. Okay, make sure you know how to do these, that you have to factor. All right, question number 2. We have log base 4 of 2x minus 10 equals 3. Now, I'd like to solve for this, but I can't because the 3 on the other side. I got to fix it first. So log base 4 of 2x minus 10 is log base what? What do I put? 4, right? It has to be the same base, and then copy it again, 4, right? And put that power up on top. Once you have your logs matching, excuse me, once you have your logs matching there, you're going to set the inside portions equal to each other. 2x minus 10 equals 4 to the third. Okay? So 4 to the third is 64. So let me write that down. And then just start solving for x like you normally would. So add 10 to both sides. That's going to give you a 74 equal to 2x. And then divide by 2 and you're done. So if you divide by 2, you get x equal to 37. Now, you're going to want to check it just to make sure. So let's plug it into this part right here. Okay, the part inside the logs. We're only looking at the stuff inside the logs. So 2x minus 10 will be 2 times 37 minus 10, which is 74 minus 10, which is 64. That checks out just fine. So that means this answer is correct. As long as my check step comes out positive, it doesn't have to be any specific number. It just has to be positive. That's all. If the check step comes out negative, then I cross out that answer and I say no solution if there's no other options. Right? Are we okay so far with questions 1 and 2? All right, question 3 is a little bit easier. Notice we have logs on both sides this time, and they're both the same logs. That's good. But we do have like expressions on the inside, but that's not a big deal. Since the logs match, then all I have to do is set the insides equal to each other. Okay, and then just start combining stuff. So let's move the 2x over to the right side. All right, so we have 5 equal to 4x minus 15. Like I said, this part you guys should be good at, right? You've been doing this for years and years and years, right? Just add 15 on both sides here. So 20 is equal to 4x. And then just divide by 4. And remember, you got to check. Make sure you check that it works on 2x plus 5 and 6x minus 15. So we're going to do a check step real quick. Again, I know that's annoying. The check step's always annoying, but unfortunately for logs, we got to make sure that our answer on the inside, once we plug in our answer, doesn't come out to a negative number, because if it does, then it messes it up and it doesn't work. So we got to see, does this work? So if I plug in a 5 into 2x plus 5, that comes out to 10 plus 5, which is 15. So that's good. So far, so good. Now let's plug it into the other one, 6x minus 15. So 6 times 5 minus 15, that's 30 minus 15, which is 15. That's positive, that's good. So this answer works. Remember, we have 8 examples. We're getting halfway there. We've already done, I think, the harder ones, just so you know. I think the rest of these are, not that they're not difficult, but they're not as difficult as, say, the first example. Any questions on number 3? We'll move this up a bit. All right, so let's look at question number 4. So I'm going to move it just a little bit more. I know some of you guys were trying to get the answer at the very bottom, so I'll leave it there. Log base 2 of 4n equals to negative 3. Okay, now you'll notice, obviously for this problem, there is no log base 2 on the right side. So let's put one there. So log base 2 of 4n equals log base 2 of 2. Remember, always copy that base, right? So 2, and then there's a 2, a big 2 there, and then use that negative 3 as the power. So now since they both have a log base 2, get the inside portions and set them equal to each other. So 4n equals 2 to the negative 3. Now, what does a negative power do? What does it do to the number? It flips it, right? So this is 4n equals 1 over 2 to the third. Remember, once you flip it, the power becomes positive, okay? Now, 2 to the third, that's an 8. So this is 4n equals 1 over 8. And in order to solve for n, let me move this over here. I'm going to just rewrite it really quick. I'm going to divide by 4. So n is equal to 1 over 32. Okay, and that's our answer. Now you can check it, okay? So we can check it with the 4n right there. So just to check, it has to come out positive. 4 times n, which is 32. That's, oh, it's an 8. Sorry, I don't know why I was having a hard time remembering what that was. That's a 1/8. Now 1/8 is positive, so we're good. This is a good answer. Now, again, we're assuming that I did the math properly, so that's why I say it's a good answer. If I would have messed up my math somewhere, then obviously the answer is not correct. But I feel pretty good that I did that stuff right, so we're good. Okay, so main things you guys got to remember: if the logs are not on both sides, make sure that you make them show up on both sides. Always check your answers. Right? Check your answers with the actual log functions. Make sure that they're able to be plugged in. Because if you see any problem, because remember, you're going to have multiple choices, right? And there's going to be some fill in the blanks. But if there's any problem that's multiple choice and you see a no solution, you better make sure you check your work. Because no solution may be an option because the answers you found may not work. Right? There's only one reason why they would put a no solution in there, if maybe some of them don't work. If you do see a no solution, don't automatically just check it off and say, oh, look, no solution, it has to be it, right? Sometimes they put them in there just to kind of see if anybody just randomly picks it. But yeah, if you see a no solution, for sure, check your work. If on the multiple choice there is no solutions and you only see your answer, then pick it, because you don't have to check it. You found the right one. So it just kind of depends. Look at your options and see what you need to do. All right. So again, going through 5, 6, 7, and 8. So 5 is, I would say, the most challenging one of the next 4. These are not too bad. I know they don't look nice, but they're not too bad. These are the exponentials that I wanted to go over with you guys. So let's get to work with these. Now, in this problem, you're going to notice that in front of the log, there's a negative 8 that's multiplying. You're going to want to get rid of it. So the way you're going to do it is you're going to divide by it. Okay, so divide by negative 8. Okay, so we're going to have log base 3 of x minus 1 equals to 3. So this is going to look a little weird on the right side. Because when I write out the right side, what am I going to put? Can someone tell me? Log 3, right? It's going to be log base 3 of 3 to the third, right? So it's going to look a little odd. But now that we have both sides with log base 3's, I can get my x minus 1 and set it equal to 3 to the third, which is 27. And if I add 1 to both sides, my answer is just 28, right? X equals 28. So just to check, if I plug in a 28 into the x minus 1, is it going to be positive? Yeah, right? If I plug it into here, it's going to be positive. 28 minus 1 is 27. It's good. So there's my check step. I just did it in my head. Okay, this is going to work. No problem. Remember, a lot of log stuff, it's not that they're difficult to do. It's just you have to know the right tricks. And once you get the right trick done, then they're easy to solve. But you still have to know the properties, right? The tricks to try to rewrite stuff. All right, number 6. Remember earlier we saw an addition of logs we multiplied? Number 6 has subtraction, which means you got to divide. Okay, so here you're going to do log of negative 4x divided by 2 equal to 1. Okay, that minus makes you divide those things in that log. Remember, this is a log base 10, just so you know. Negative 4x over 2, that's a negative 2x. So I'm going to write log of negative 2x equals to, what do I write there? 10 to the 1, right? 10 to the first. So negative 2x is equal to 10, right? Because they both have logs. So that means I can just set the insides equal to each other. If you divide by negative 2, you'll find your answer of x equal to negative 5. Will negative 5 work? Now I only got to check it on the left side, the negative 4x. So negative 4 times negative 5, that's a positive 20. So that's good. That works. The check step will work. So here we go. Notice when the check step is easy, like it's just a simple little thing to plug it into, I don't usually show the work. I just kind of look at it and say, okay, what would happen if I do this, right? That one's not too bad. Negative 4 times negative 5 is positive 20, so I'm good. I don't have to plug it into the log of 2 because there's nowhere to plug it into. There's no x, right? Just into the first one. All right, these last two problems, before I move on, the last two problems are exponentials. So before I go into those, do you guys have any questions on numbers 1 through 6? I know if you came in a little late, the notes will be up there, the video will be up there, everything. You can always review it later, so don't worry. It'll be sent over to you guys. So you guys are okay with 1 through 6? All right, so let's look at 7 and 8 then. Before we do 7, let's look at 8. Because 7 is a tougher version of number 8. So I gotta solve for x, but x is a power. The power of x has to be brought down, and the way we do that is by introducing logs, okay, or natural logs, but we'll just go with logs, okay? So you're gonna write on both sides log of 4 to the x minus 2 equals log of 10, okay? You're just gonna introduce a log to both sides. By doing that, it allows this power to drop. So it's going to become an x minus 2 log of 4 equals log of 10. Now notice, I got to get that x minus 2 all by itself. So let me get that log of 4 out of there. It's multiplying, so I'm going to divide by it, okay? I'm going to divide by log of 4. So all I have is x minus 2 equals to log of 10 over log of 4. Now I don't know what that answer is, but let's calculate it. So I'm put log of 10, which should be 1, divided by log of 4. So let's say it's 1.661, okay? So 1.661. So just add 2 to both sides and you're done. So x is equal to 3.661. And there's my answer, 3.661. Notice we did need a calculator for this. There will be problems like this on your test where you're going to have to use a calculator, okay? So please bring yours if you have one. If not, I have some here. If you're looking into buying one, guys, if you need me to recommend one, the ones that I was telling you guys, the ones I had here that people were taking from me, those are really good, and they were only $10.99, super cheap, and they're really good, okay? You can go and buy crazy expensive ones and never use the full power of them, but those $10.99 ones on Amazon, they're like really good, okay? So definitely a good investment, especially with school. So all right, let's go back to number 7. Now I want to solve for x, but notice 2 to the x plus 2 is being manipulated by a 3. It's multiplying, and then at the end there's a minus 2. So what you want to do in this situation is ignore the multiplication right now. Get rid of that minus 2 first. Okay? So you're going to add 2 to both sides. So you end up with 3 times 2 to the x plus 2 equals to 9. Okay? Now, let's get rid of that 3 times portion. Since that's multiplication, we're going to want to divide. So I get 2 to the x plus 2 is equal to 3. Looks like a weird 3. Once I've cleared everything up and I have my base with my variable, all I have to do is introduce logs and then start solving like I just did in number 8. Okay? So let's introduce logs into this. So this will be log of 2 to the x plus 2 equal to log of 3. And remember, once you put the logs in, this power can be brought down to the front. So to kind of show that work here, that's x plus 2 log of 2 equals log of 3. Just like we did in the previous example, I want to get my x plus 2 by itself. Let's get rid of that log of 2. So we're going to divide it out. Log of 2, log of 2. So it's going to be x plus 2 equals to, now I don't know what log of 3 over log of 2 is, so let's find out. So log of 3 divided by log of 2 is 1.585. I'm just rounding it, so 1.585. And I have to subtract 2. So let's just get our answer and subtract 2 from it. So negative 0.415. And that would be my answer. Okay, so those are all 8 problems for you guys. Make sure that you go over them tonight.